Hello there. A digital meter is used to measure the current in an electric circuit. The reading on the meter fluctuates, i.e. varies between 3.04 amperes and 3.08 amperes. The readings on the meter have an accuracy of plus minus 1%. Question is, what is the true value of the current with its uncertainty? Now, for this question, you have to be very careful and understand. That means you need to read the question carefully, because it says here the reading fluctuates or varies between 3.4 and 3.08 amperes. What does it mean? It means the digital meter is used to take one reading, only one reading, but the one reading is fluctuating between 3.04 and 3.08. Because some students that I find out that they thought that this is I1 and this is I2, and they just want to take the average and to determine the uncertainty, just add both of them together, when in fact this is just one reading, but the issue is the digital meter is fluctuating, probably because when we do practical, this fluctuation of the readings might be because of the insecure connections between the crocodile clips and so on. So we have to understand first what the question is actually asking. So this is not I1 and I2, but instead both are basically I1, but the reading is not stable. So it just keeps on fluctuating. Now, given this current situation, we need to calculate its uncertainty, because we know that the average value is just 3.06, because all of the available choices are actually 3.06. So we just can't be bothered to find out 3.04 plus 3.08 and then divide by 2, you get 3.06. Now, how do you go about this question? Basically, we know that the accuracy of the digital meter is plus minus 1%. That is just for a single reading. That means if you go for the minimum value 3.4a, 3.04, and then you got 3.08 amperes. That means the minimum would be minus 1% of this reading and plus 1% of this same reading. So similarly, it can go to minus 1% and it can go to plus 1%. Now, these two readings, or this what we call the range, minus 1% of 3.04 and plus 1% of 3.08, would give us the possible range of values that is detected by our digital meter, which is not really that accurate in this case, because it keeps on fluctuating due to the insecure connections. So what we can do in terms of determining the uncertainty of the current here is basically you just have to find out what is the minimum range and what is the maximum range, and then you find out the range rather than the average, and then just divide by 2 so that you can take the plus minus of the uncertainty. Now let's do this. If we take minus 1% of 3.04, which is 99.99 times 3.04, so you will get the minimum value that it can go is basically 3.0096 ampere, and for the maximum value 1.01 times 3.08 is basically 3.1108. Now this is the possible range of current detected by the fluctuating ammeter. So you can just simply, so this one would just be I min and this one would just be I max. So the uncertainty will be I max minus I min, just to take the range, divide by 2. So it will be 3.1108 minus 3.0096 divided by 2. So you will get here 0.0506 ampere. This will be your uncertainty. However, always remember, all uncertainty values must be up to only one significant figures. Okay, so automatically you will know that the uncertainty for the current will be 0.05 ampere. So where the answer is A. Now, just to add some more information, which is probably not related to your, and if you want to answer MCQ, but if you want to answer paper 2, for example, all uncertainty values must be in one significant figures, but the measured current or the measured data must follow the same number of decimal places here. So although here is one significant figure, which is the uncertainty, but how many decimal places are there? There are 2 decimal places. That means we need to present our current into 3.06. This one no problem because it has already got 2 decimal places. So it has to be consistent with 2 decimal places corresponding to the uncertainty value. So we add plus minus as the answer as shown in C is because the possible range of values that spans from I min to I max. So the middle value will be 3.06. So our current, or the true value of the current, would be 3.06, but we have a certain level of uncertainty plus minus 0.05. So it can be probably it can be 3.1108 or it can be 3.0096. So that is what we call uncertainty of one single reading, but the reading of a digital ammeter is fluctuating.